I'm going to show you how to use technology to conduct a hypothesis test for the mean. The problem states that the commercial for the new Meat Man barbecue claims that it takes 13 minutes for assembly. A consumer advocate thinks that the assembly time is higher, of course, than 13 minutes, and he also believes the assembly times are normally distributed. The advocate surveyed 10 randomly selected people and found that their average assembly time was 14.7 minutes, with a standard deviation of 2.1 minutes. What can be concluded at the alpha equal 0.1 significance level? Let's write down what we know. We're given that the claimed mean for assembly time, that's mu0, is 13. We have a sample of size 10, and it shows an average assembly time of 14.7 minutes with a standard deviation, S, of 2.1. And our significance level is 0.1. For this study, we should use, and our options are a z-test for proportion or a t-test for a mean. And we want to use t-test for population mean. And we can do that even though n is less than 30, we're told that the original population is normal, so we can use that test. Let's state the null and alternative hypotheses. The null hypothesis always contains the equal sign. So H0 is that mu equals 13. And the alternative hypothesis, the test that we're claiming in this case, is that mu is actually greater than 13. Now, since this inequality points to the right, this is a right-tailed test. And that's the information we need to conduct the hypothesis test. So I'm going to come over here to the list of calculators from LibreText and select hypothesis test for mean with statistics. The population standard deviation is unknown, so make sure that's clicked. And then just fill in the boxes. S is 2.1. The sample mean was 14.7. N is 10. And the mean in the hypothesis is 13 minutes. And since it's a right-tailed test, click right and calculate. And there we get both the test statistic and the p-value. So let's record those. The formula for the test statistic is actually here, but we don't need that because we're having a calculator do it for us. And I believe this problem wants 3 decimals. So to 3 decimals, this is 2.560. 2.560. The p-value, let's record that while we're here. P to 4 decimals is 0.0153. So what that means is our test statistic is here, 2.56. And the p-value for a right-tailed test is the area of this tail right here. So this tail has area 0.0153. And that's the probability that if H0 is true and we sampled another 10 people, we would get a test statistic as extreme as the one we got. So what should we do in this case? And the rule is, I always tell students to remember, if P is low, the null must go. So if P is lower than the significance level or equal to it, then we reject H0. If not, we fail to reject. In this case, 0.0153 is less than a significance level of 0.1, so the null must go. We reject H0. And our final conclusion is that the data suggests the population is significantly higher than 13 at the 0.1 significance level, so there is sufficient evidence to conclude that the population mean amount of time to assembly the barbecue is actually higher than 13 minutes. I hope this helps.